Hello. Hope everyone will be able to hear us, see us. It's a nice temperature today for doing a webinar about simulation. So we will have a real simulation also with the temperature at 35 or 95. So real compressed air system simulation. And yes, turn your camera off. The questions will be at the end. I will unmute you. So we will have a stream for 15 minutes. This type of presentation webinar will be actually for simulation as a workshop. So we will work in a platform as a series of presentation. Today's presentation will be actually the most simple one to select the right compressor, the right size, the right model, the right brand, whatever, with the goal of the best efficiency. So I will guide you with some basic information, how to get the data, and then how to actually start the simulations. So my colleague Rock is also here with me. Hello. And we will try this to do in 1 hour or maybe even less, to have 10 minutes at the end for questions. So let's go for the first slide. I hope you can see it. Just a little bit about ourselves. I'm Boris Bregar. I worked with compressed air for quite some time, maybe 30 plus years. We started the CALMS project, which is, let's say, independent platform for compressed air management with the holistical approach. So we wanted to combine everything in one single platform for complete compressed air management. And this is also where we actually take the data and put into the simulations. We are independent from manufacturers, so the results of the simulations are independent results, models, and the system that we created is actually action-driven, so it will use the simulation also in the background, help you with action-driven cards for opportunities, and all the other saving options. Our system platform is based on standard 837 for monitoring and ISO 11011 for waste management, and we support also 50001 energy management and 55,000 asset management standards. And we are part of CAS coalition worldwide, which started actually officially last month. Okay.
A little bit about myself as well. My name is Rock. Compared to Boris, I'm a beginner in compressed air. I only have 18 years of experience, and my specialties were compressed air measurement, and lately, for the last 5-10 years, with audits, and now with the CALMS platform specializing in simulations. So if there are any questions pertaining to simulations especially, I'm here to answer.
Thank you. Okay, so about simulations, why do we use them? How we integrated them in our platform? So actually, the simulation is the process of transforming the real system. We are talking about the compressed air system to the computer model. We are using some equations, some models of the equipment like compressors, and we are using the flow profile together with the power and pressure profile to identify. And of course, while we use this simulation to optimize the system without actually changing the equipment, changing the system, we can first test it. There is a buzzword which is called digital twin. So you can test this and then you can apply what was tested. So in columns, we use simulations for understanding the compressed air system. With the simulation, it's a perfect tool to learn about the system, how it works, and where there are some problems with the system. You can identify them. You can test, verify the measurements, which is also a quite important part of simulations. And with the digital twins, yes, you create the model, the PID schematic of the system. And you can actually, before you buy a new compressed air system, you can actually test and simulate on the flow profile that is the input to the simulator. In case your production level increases with the new production lines or decreases, you can do the simulation, run the simulation, and see if your existing compressors are good enough, big enough, or you need to change them. You can do, of course, comparing the compressors when you buy the new equipment, receiver, dryer, compressor. Then when you are actually adding a new control system or master control system, before you do that, you can simulate, you can actually learn how to program and how to prepare the best control system to set the control system, or actually to create the functions that are related to the production and the air consumption. And of course, you can test also the flow controllers, many other sorts of problems and opportunity in the compressed air system. So during this series of presentation, we have 5 such series. We will guide you through each of different use cases as a workshop. So the first one will be the easiest one, buying the new compressor. But maybe at the end of those series, you will find out that maybe this is not the best action to do in this particular actual system. With the simulations, of course, we have also some limitations. The first one is the quality of data. So yeah, you heard many times, if your measured data is garbage, also the output will not be the best one. So you can verify, you must be convinced that your monitoring and measuring equipment is good enough. Then when you create models, you need to get as good as possible the performance, the characteristic of the equipment which you put in the system. And at the end, what is also very important, and the limitation of the system, it is maybe we tried as hard as possible to design the simulation for regular guys using the compressed air, but actually it is still more designed for compressed air experts. You need to evaluate the results, like with ChatGPT, you need to know when the answer is good or not. So it is very important, and this is also the limitation at the moment of these simulation systems. Okay, the guides, there are 6 steps how to come before you start the simulations. First, you need to create the compressed air model. So this is normally done with the system review or audits. When you create the PID schematic, process instrumentation diagram of the compressed air system, you select different compressors with all the performance data. Then you start collecting data. We call this audit. Normally, the minimum period is for 1 week. We suggest more, maybe 2 weeks. We have still the limitation because the compute power is quite high. The CPU usage of the servers is quite high. So if not special request, the limitation is for 2 weeks of collected measurement data. The third action is actually simulation period and the flow profile. The basic data that we need is, of course, a flow profile and the power usage and pressure usage to compare the measured data with the actual result of the simulator and verify the model, which is the next step. So when you start the simulation, you need also to verify that your model is good enough and that the results based on the simulation, on the model that you create, are very similar to the measured data that you get from the audit. Then you start many simulations, changing the parameters, and you can compare all those simulation results. And at the end, of course, you select and validate the results with the compressor expert, with someone who understands actually the result of the simulation, and then you are ready to implement this in practice. So this is a little bit more graphical presentation. It's more or less the same. You have a factory with many compressors. You do the measurements, collect the data with the edge devices. We are streaming this data to the cloud servers, and together with independent experts, it's complete processing independent from manufacturer. So they will validate the data, and they will also validate the models, and their know-how, they will help you to fine-tune and set all the parameters in the simulator. This simulator can be also part of the auto analyzer, which will give you actually the recommendations, the actions, the opportunities that you can perform to make the efficiency of the complete system better and get the savings. Okay, this is actually our standard design. I would like to talk about this 5-10 minutes just to spend here to understand how we collect the data, prepare the data, and then we start running the simulation. So we are using at Scalance different edge devices. It's a permanent, it can be from permanent monitoring, so you can do this continuously, or you can use edge devices for audits for 1 week, 2 weeks, 1 month, collecting data from different locations, different compressor rooms, and sending this to the cloud with the different view. And for expert view, we enable also the simulator. With the system review, with the Android, with the mobile application, you collect the manual data, which are also fit to the same system for the final audit. So from this step on, we will move to our real platform. So we will guide you through different steps. I will do the first steps, and then Rock will jump to the simulation process, start the new simulation, and show you the results on only one thing, which is today purpose. It is buying a new compressor. And those steps that are described here, from first creating the system in our platform, setting up the PID, the model of the system, selecting the right slice. This is the reporting period on which you will perform the simulations. Under the simulation page, you start the simulation with the different profile settings. Select the right flow profile, and then based on this, verify the module, start the simulation, select the compressors, equipment, different controllers, and at the end, when you select the best simulation results, you can create the final report. So now I will jump to the actual system. Here and share. Yes. The first one, yes. Okay. So we are in a first webinar simulation system. I will go from the beginning. So this is the setup where you start the system. You put the major information about the compressed air system, the annual operating hours, electricity cost, compressed air cost. You can use different tools, CO2 emissions. Those are the basic informations. Then we have to jump to the equipment, where we create the actual PID drawings. You can select, of course, your different compressors. Our system will guide you and give you an option to select thousands of different compressors with the characteristic from different databases, like AGI pages or data sheets from different manufacturers, or columns data sheets, or your own data sheets if you have one. So you can just select the different type of the compressor, And here in the system, we'll fill all the necessary data that are also needed for the model, like operating pressure, full power load, max power, power at zero flow, and nominal capacity, design capacity at this flow. All the data that are necessary for this system to operate. Then the next step, of course, is the system assessment, system review. We will skip this. This is not the topic. Then we go for an inspect page. Here in the inspect page, this is actually designed for compressor experts. We have to find the data, the measurements data. So hopefully they will be here. This is 1 year data period. I will zoom in. We will select the data that are important for this system. There are many data that you can select, of course, like calculated flow to compare. So I will have just basic data. From this slide, you have many tools on this monitoring page that you can compare. You see where are the problems. You can limit this. Okay, we will analyze. This is the typical week. I can zoom in to 1 week time like this. I can actually go for a different slide, so to see different variables, different channels in a separate channel. I can check here all the parameters for this particular 1 week time. I can do the averages of these all signals, the totals. Then when I analyze this to understand the data before I go to the simulation, I can do the aggregate data. Where I can compare to the target specific power. For example, if my target specific power, sorry, we are talking about the metrics now. You can anytime change to US units, so no, not a problem. I'm changing here the different target specific power, and on the QSUM graph, you will see the savings or losses of the existing system together compared to this target system. If I change this to like this, you are actually saving. You are better than this with the existing system. And here on the empty diagram, you see all the points which are better than your target specific power and which are worse. So our aim today is to reach, let's say, 1.15 target specific power. We will see if we will manage this. So the majority of points that are collected are here, the red one, which are worse than our target specific power. The green ones below are better. So we see that there are different regimes of operation in this compressor room. And we need to optimize for a low end consumption for also for some combination of the compressor, which is totally inefficient. But this, you will learn how to improve this particular system during this operation. So when I select the right period, this is, I selected here for 1 week, I will create a new this is the period for which I would like to do the simulation, like this. Simulation number 1. Okay, number 1. I will select all the channels that are related, or I can select only the channels that are related to the inspection. It's better to have all channels available, and I can create the slides. So now the system will jump immediately to the slides where we can actually use all the functions that are related for compressor experts to analyze this, create the new calculation channels, inspect, analyze the data. All the data that we are storing in our system are based on 5-second sample rate, or 1 second, or even less if needed. That's due to simulation, so that we can actually, because some actions of unloading, loading can be very fast, and you need to have at least 5 seconds for doing a proper simulation. Oh, so here we have different tables, table view, histogram view, where you can compare the data, analyze the data, check the correlation between different signals. You can put the histogram on this chart. So actually, you can do this on a, let's say, hourly base to get more points. I mean, those process is quite consuming. So with this tool, you start analyzing the data before you actually go for the simulation. Okay. Then at the end, we come to the simulation. This is the empty simulator. Okay, and where you can start the new simulator. But because we have already ready some simulations, we will go back to analyze and we will show you actually already created one, and you will be able to see also how the process. But before we do that, I would like to show you also the different analyzers, like the capacitance, the compressor combination analyzer, on-off compressor analyzer, and PSD compressor, and many more that will come, and you can open them and use them to play with different type of combinations on a different scales like this. So you actually can see what different compressor can contribute and how can it contribute to your consumption. Okay, so now I will jump out of this and we'll go to the simulation. There are many simulations for this system, and today we actually need to go with this one. Yeah. Today, number 1. Okay, I will go this one, and Rock, I will give this to you.
Thank you very much. As Goras mentioned, there are quite some steps necessary before you get into the simulation, and a lot of those steps include knowledge that you accumulate along the way, which help you, which guide you to a better understanding of what might be the problem or not with a particular compressor station, and what sort of results, what sort of cases you would like to simulate. There are certain simulations you can do which may not be useful in a certain situation, or they could be. And the steps that you do before you start the simulations will be able to guide you into which simulations make more sense. One of the simulations that makes sense some of the time, not all of the time, is to replace one existing compressor with another compressor in the hope that this will better the specific power and therefore the used energy of the compressor station. So today we will do that. In our system, first of all, we can just have a look at the, well, even better. In the simulation, we have the measured data. I've actually created it beforehand, but we can easily create it again. And one of the, I'll delete the measured data and we'll create it again, which is right here, but can compare with measured data. And as we've done the review and entered the PNID diagram beforehand in the setup panel, all of this is very automatic. So we will select the flow channel, which represents our system flow, and this is this channel. We can select our system pressure, so we have an idea of at what pressure our compressor station is running, and of course the compressors that are used, and 2 of them are in this system at this time. So we will save this, and immediately we have the measured data, and we can have a look at the measured data. This red line represents the power over this 1 day of data. This is not simulated data, this is real data. We have the pressure, and we have this is the power of one of the compressors. The yellow is the power of another. There are 2 compressors in the system, and the flow is this blue line here. We see that the specific power of the system is not very good compared to the average power. power is just over 200 kilowatts. The average flow of the system is 28 cubic meters per minute. And the specific power of the system is 0.13 kilowatt hours per cubic meter. Not the best, not the worst. Can we do better? We can try this with a simulation. So let's try with a new simulation. I have already created one simulation here, but we will create another one, fly. And this is done here on the right-hand side with the new simulation, where we will select that same channel, flow channel, that we are going to simulate. We open up advanced options to have a look at the flow profile that we are going to simulate. Looking closer to the flow profile, we see a lot of very, very high spikes. These high spikes may be because the flow meter is placed very, very close to the compressors, perhaps even before the storage vessel. And I know for a fact in this case that is what is happening. So trying to simulate these sort of spikes is not going to simulate reality, because in reality, the demand flow is not this spiky. This is the production flow. We can smooth this out in various methods. One easiest method is just to take an aggregate. Oh, I've done it this the wrong way. Here we go. An aggregate period, which is not as long. Okay. This is the 10 seconds one, and of course, if I go to 10 minutes, the aggregate period being longer, the average flow, of course, is a smoother profile. And so let's accept this as the demand profile. It doesn't matter at what aggregate you're doing. The total flow will be the same, and the average flow will be the same. The profile will be different depending on what aggregate, depending on how you do a moving average of the flow. Once that is done, you enter in some of the basic properties of the system. Well, the first basic property is the size of the system, which is actually entered into the setup. You enter this data again. I know that the system is around 30 cubic meters. So this is the sum of all the pressure vessels is 30 cubic meters. Now we start to add the compressors.
Sorry, Rock, you skipped the very important part, system description in the title.
Oh, I see.
This one.
Yes. Okay. Every simulation can have its own name. So let's call this this simulation. We can just add in here webinar, and of course a description which will help when we're making a report of many simulations that we have. So we will know which simulation we did. We will describe this simulation as let's say choosing new VSD compressor, right?
Maybe 200 horsepower, 200 kilowatt or something.
200 kilowatt. Well, let's have a look at the flow profile. So we get up to about 44 cubic meters per minute. A 250 VSD will not suffice, but we do have two compressors in our system. We will be only exchanging one of them. So one can be a backup, and the VSD will have to take care of the rest. I agree with you. I think 250 kilowatts, between 200 and 250 might be a good idea. We will try that out. So we will now select the first compressor, one of the compressors that are in our system already. So for the source, I will just choose our system. And in our system, in this compressor station, there are two compressors. Both of them are quite old, and they are comparable to each other. So let us perhaps choose this first one, and this is the compressor that we will be keeping. The other one we will exchange for a different compressor. So we will add another compressor, and when filling data, I will not choose the manufacturer. I will just choose what sort of a compressor I need. So I need a compressor between 200 and 250 kilowatts. I have to.
Different database.
Of course, I will select any database that I have as an option. I do have to choose oil-free because the plant is oil-free based, and I would like to choose a VSD. Yeah, okay. So we have quite a lot of compressors to choose from. Most of them have this called, they are the best and oil-free. We could, for fun, choose not to choose a VSD model. We could choose a fixed speed model. Perhaps that's an idea, but our idea for today was just to use a VSD, so we'll keep it like that. And we know that the compressor station is running at about 8 bar. So let us imagine that this compressor would be a good choice. We could, of course, choose any of these compressors. Most of them are the same, just the same compressors, but the data is at different measuring points. So we will take this compressor. These measurement points are taken from the TSAGI database with the power at zero flow, the operating pressure, the unload time, which is not in the TSAGI database. We have defaulted at 45 seconds, and the pressure drop from the compressor through the air preparation, so the filters and the dryers, we have defaulted to 30 kilopascal. And then we have a normal minimum working time of about 600 seconds, and 120 seconds is the minimum working time after unload. These are also default values. And now we are at the controller. We will be using just a local controller in both cases. And we will set this up. So we are going to try to set the pressure at the set point of 7 bar, and we will have this VSD be unloading and shutting off at 8 bar. In case this compressor is capable of handling all of the flow, which it will not in some of the cases, as the flow goes all the way up and beyond 46. So we will add this compressor, and we will load this compressor, of course, a little bit lower at, let's say, 6.5 bar, and we will have it unload just above the set point at 7.2 bar, which I think is a standard operating procedure for 2 compressors in running in a cascade system. If I have not forgotten anything, we should have a green save, which we do. I will save this data. And the simulation is ready for us right over here. And with the play button, we run the simulation. And that is it. That is how long it takes for one whole day of simulations, simulating 2 compressors, 2 powers for every single second, and calculating the pressure. Let's have a look. At the beginning, if we have a look at our measured data, we have 2 compressors running, the red one and the yellow one. Why they are running like this is not part of our seminar, our webinar today. What is using the simulations to simulate different outcomes. One of them today being selecting a different compressor. If we do that, we will see that with the low flow profile, the the VSD compressor has to unload as it is lower than its minimum capacity. As the flow profile rises, so does the power, and it starts to run as a VSD would. And the VSD is large enough that the second Atlas Copco compressor doesn't even run. We can check that here with our stats, our statistics, and our original compressor that was still in the compressor station has now turned into a backup compressor. It has 0 starts, it hasn't loaded, and it doesn't have any running time compared to this new compressor that we have chosen, which has a total running time of 24 hours, which is the period here of our simulation. And with the average power of 183 kilowatts, it has a specific of 0.106 kilowatt hours per cubic meter. So choosing this and comparing it to our measured data, we have a lovely button right over here where I set this measured data to 0, and our new simulation, this was one that I simulated myself earlier on, obviously did not choose a compressor that was so good. We've chosen an excellent compressor in this case, at least in my opinion, and have dropped the specific power by 19%, where the average power of the measured data is 226 kilowatts. We have now dropped the average power down to 183 kilowatts, bettering the specific power by quite some margin. The pressure that we are holding is almost exactly the same as what the measured data reveals. So our average pressure has gone down about 4%. The minimum pressure is actually higher by 1%, and the maximum pressure is also higher, about 5%. So we are holding the pressure quite nicely, and we have done quite a good job at dropping the average power. Later on in this series, we will find that this is not the only simulation that can better the specific power. We might even find that certain different simulations will come up with perhaps not as good an outcome, but the price performance will be much better. What we have is the purchase of quite an expensive compressor to exchange a compressor that is still running, it's not broken. So the investment is quite high, but the return on this investment is also, I'm quite sure, quite short in this case. Further investigation in later chapters might find that there are options that are even cheaper to achieve almost the same outcome.
But you didn't talk about the money yet. So maybe there's just one nice feature here. You can change and play with the electricity cost. So if it's not 0.28 cents euro per kilowatt hour, maybe you can put this 1.5 or something like that.
Fine.
So here the cost, the total annual cost prediction based on the operating hours, if it's 8,760, you will get, this is the total annual cost for electricity for this particular, for measured data, for original system. And for simulated system, actually, you have here the annual data. So with the cost of electricity of 15 euro cents, you got the difference of almost 50,000 euro per year, which is quite reasonable. Of course, if you increase the price, sometimes now it's 25 cents. Of course, the difference, yes, now it's 500,000. 500,000 per year, and here is 100,000 difference. So you spend 100,000 euro less electricity. the investment of this size of the compressor would be 200. So the return on investment here in this case is what, about 2 years?
Yeah. Yes.
So yes, that's
Especially if you can get a good deal on the compressor, could be less than 2 years.
exactly.
But anything below 5 years, I think, in today's market is quite good. I know that in Slovenia and in most of the European Union, if it is an energy saving investment, then even 10 years is acceptable. But of course, a return of investment of 5 years, a simple return of 5 years or less, is absolutely excellent.
Okay, I hope I'm presenting the last slide, which is actually the invitation for the next webinars. They will all be about simulation. They will start almost the same like today for the different audience, but actually the topics will be different. So if today we're talking about buying a new compressor, replacing the old one with the new ones, the next will be on the same system, or maybe a different one, I think on the same, what will happen with if you install a control system. There was no control system, you can install a control system and see what would be the differences. The next simulation workshop will be to selecting the flow controller, the savings with the flow controller.
Yeah.
The last one would be selecting the right receiver. And maybe even more important one is to analyze the system, to understand the system, because Rob already mentioned that this system had some strange behavior, and with the simulator you can find this very easily. And when you compare the model with the existing measurements, you immediately see that the model will not work out of the box. So you will need to correct this, and this will be maybe the last presentation for really experts on the compressed air to understand how to perform this. So maybe now it's time for some questions. We have about 10 minutes. So if any questions, write them down, or I will stop presenting. Oh, you're here. You can unmute yourself and
Can have a look. May I read out some of the questions?
Start with the first one from Robert, maybe.
Yes, I will.
Let's raise the easiest one.
I'm trying to just quickly. One of the questions, Gorazd, can we guarantee the savings? Maybe just 50%? What, of all the savings possible?
Yeah, that's a good question. Can we guarantee the savings with our simulator? Yes, I start talking with the limitation. If you can guarantee with the measurements of the flow profile and the power of the compressor, then yes, we can guarantee the results of the calculation, and we can guarantee this. I would say 5-10%. If everything is
5-10% for sure.
Yes,
Because
really, yeah.
we have done many simulations just to test our model, and once we were absolutely sure that all measurements were correct, that the flow meters were showing exactly correct, that we had the right capacitance of the system in the system, and this is something that we can do. We can check if something is wrong. If you don't set up the simulation properly, you just press play, you're going to get all sorts of funny results which show up immediately, and if the results are funny, there's something wrong, and you don't stop until you find out what is wrong. And once you've eliminated all errors, you get a difference of less than 3%.
With
Less
the
than
model
3%.
and the measured data.
Yeah.
And that's the verification of the model. Once you have the model that is the same, that gives you the same results that the measurements, then we can guarantee the savings in the same range of the difference. So it can be as at 3%.
Yeah. We have another question. Do we have 50 hertz air compressor data in our system? The answer is yes. We do have 50 hertz. We do not have 50 hertz from the Zagi sheets because the Zagi sheets are all 60 hertz. But we have had some manufacturers come to us with their data sheets. We have added them in. They are for 50 and for 60 hertz, and it is stated especially where the source comes from. So if you choose just from the Zagi database, if this is your opinion that the Zagi database is what you want to use, you of course use that. If you are happy to use a different database, you're welcome to use that. And it is stated from which database we get our data, and a lot of the data is also for 50 hertz compressors.
The questions simulation works if the buffer size is adequate.
This simulation works if the buffer sizing is adequate. If not, Mr. Robert, I would like to meet you. You are absolutely right. If the buffer size is extremely small, then it is very hard to control the VSD in our system. Hello, sir.
Hello. How are you?
Yes, it is. There are two things that our simulator has trouble with. If the receiver sizing is extremely small. But what I am talking about now is theoretical. So with a size of compressor station that is good for, let's say, a 250 kilowatt machine, if you put in a pressure vessel of 150 liters, then the VSD goes crazy. Yeah, and I cannot fix that. And another thing is with the pressure vessel, and then I have a pressure drop. And with a very small pressure vessel, we have an automatic pressure drop between the compressor and the pressure vessel. As we imagine, there are some some air preparation units between, some filters, some dryers. And as the VSD has to pick up because the pressure drops, so the drop in pressure increases as the VSD starts to run up, and this will choke the VSD. The VSD comes down, the pressure goes down, and the VSD starts to go crazy. This happens also in real life. It's not just a simulator problem. So our simulator actually does emulate the real world also in that case. But because our simulator is not limited by stretching of the pipes and stuff like that, then we do get some anomalies, like a pressure out of a compressor will rise up to 5,000 bar, because of the spike. But this is generally an error made when you're entering in data, when you enter in 2 liters or 5 liters pressure tank, when it's actually 5 or 10 cubic meters. Thank you for bringing that up. That is very clever.
Okay. Thank you.
Okay. Maybe the next one, Rock. The combination of VSD compressor and the flow controller can help when the storage is inadequate. The question.
That is a very good question. The combination of VSD and flow controller can help when the storage is inadequate. Personally, I don't think so.
No, the storage must be adequate
Yeah.
in any case.
It is true that a VSD compressor can run quite successfully even in smaller, with using small pressure vessels. But it's using a flow controller. The storage is of utmost importance. And yes, if you're using a VSD compressor instead of an on-off compressor, perhaps you can make a successful installation of a flow controller with a bit of a smaller storage. But
it depends on flow profile. If you have
Also
a
on
flat
the
flow profile or a very changing flow profile, then this is very important part. So when you do the audit analysis, you have to take in mind this and use the simulation to select the right storage.
yes,
So flow profile is important.
yes,
Flow controller. Next one.
yes. I think this is just a comment on his first question about the flow controller with a good amount of pressure differential across it. If there's a good reason for a large amount of pressure differential, then of course an inadequate storage is less of a problem if you have a good amount of pressure differential. But you have to be able to I forget the English word. You have to be able to excuse. You have to make a good excuse why you are allowing such a large pressure difference across the flow controller. Perhaps it is for the safety of another compressor, or it is to hold the pressure extremely stable, even with the inadequate storage because of the production quality. That could be a reason why holding a good amount of pressure differential, but as a energy engineer, I don't recommend a large pressure differential over the flow controller.
But you remember the system when you were in Bulgaria with 4 VSD compressor and the huge pressure differential, and they don't need the control system at all.
No,
Because the pressure differential makes the controls of
that is very true. And actually, yes, they had filters right after each VSD, and they hadn't changed their filters in a long time. So the filters were actually working as a sort of a flow controller for each VSD, and they managed to do load sharing with 4 VSDs, no controller, no anything. But as soon as one VSD tried to go up, the filter choked it, came back down, and the others it balanced out extremely nicely. A little bit wasteful, but
very efficient control scheme, but yes.
it worked. Yes. Okay, I think our hour is up. We would like to wrap things up unless there is some more questions. Can you limit the VSD load minimum to 40%? Do you mean in our simulation? Of course.
Yes.
Of course. Actually, you enter into the simulation. Yes. I will try to share the screen just quickly of the simulation, and I will open up one of the simulations, the one that we have done, and I will scroll down to this is the area where I enter in the properties of this compressor. And I have to change the name of this compressor, otherwise I cannot change the properties. So I will just call it, I don't know, VSD 33, just for fun. Now I can, of course, change. I can imagine that the compressor does not reach 111, but it will only go down to this. So I will write down here, let's say 140, and the lowest it can reach is 20 cubic meters. Now this will be the lowest point.
And you can
And-
add many.
Yes, and yes, and if I have measurements of this compressor, and I find that the actual power at zero flow, that means the unloaded power, is not 20 kilowatts, which is excellent for such a large machine, but it's actually closer to 58. That is exactly what I will write down. And now running this the simulation. If I try to run this, actually we will run this simulation. I will change the name as redone, and I will simulation. It will be under the simulation that we have just done, a redone simulation, and we can simulate the compressor. And I will imagine that we will have a different result. Yes, we are not saving as much as the compressor cannot go low enough. And if we have a look at both simulations, we'll see that we have a longer period of this compressor loading and unloading, as the flow is below the minimum flow of the compressor, whereas in this case, the compressor could go lower. I hope I have answered your question. Okay, that's excellent.
So
Are we good?
1 hour. I think we are right on time, like schedule. Even we didn't.
Best that we simulate.
It's the temperature here, so we would like to finish as soon as possible and go home to air-conditioned room. So
Yes.
any question, of course, you can send us. We will be glad to answer. We are here. You have our contacts, of course. And stay tuned for the next one, which will come in, I think, 1 week. So thank you for listening. Bye.
Thank you. Thank you very much.